In this lab, we will implement LSH framework to find all pairs similar documents with Jaccard at least 0.6. We will use 100 hash functions, D equal 100 hash functions. Choose R and B for LSH such that false negatives of 60%, similar pairs at most 10%. In order to choose the R and B values, we can calculate the false negative probability for different values of B and R. Best pair will be the one where the false negative threshold is at most 0.1 and the B value is the smallest to avoid false positives. We let B values equal np.array bracket and then the square bracket 10, 20, 25, 50 and close the brackets. B values is the array. We let Fn probability equal np.zeros of length 4. So it's an array of length 4 with all the values 0. For pair index in range length of B values, so we know that length of B values is 4. There are 4 values in B values. Range will be from range of length of B values will be range of 4 and that will be from 0 to 3. So the pair index will be from 0 to 3, 0, 1, 2, 3. Threshold, let it equal to 0.6. R values, let it equal to np.array of 10, 5, 4, 2. So for pair index in range length of B values, so this is from 0 to 3, Fn probability pair index, so from 0 to 3 equal 1 minus 0.6 to the power R values, so pair index, and then the difference raised to the power B values pair index. So say pair index is 2. Then Fn probability of 2. So 0, 1, 2. So that will be in the second space of 0, 1, 2. 0, 1, 2. So this value will be replaced by 1 minus 0.6 to the power R values of pair index. So that will be R values at position 2 at 4. So 0.6 to power 4. And then that difference will be raised to the power B values at position 2. So B values is at position 2, 0, 1, 2, that's 25. So raised to power 25. Now, so let's, I will just show you what happens. So that will be 1 minus 0.6 to the power R values in position 2. So that will be 0, 1, 2, that will be 4. And everything raised to the power B values pair index. So B values at position 2, that's 25. That's 0.03111 and so on. So you can see that when we run this function, you see in position 2, that's 0.0311 and so on. So print tabulate zip B values R values, Fn probability. So B values are um, 10, 20, 25, 50. R values are 10, 5, 4, 2. And Fn probability values are the ones that is calculated, these values over here. And the headers equal number of bands B. So for B values, number of rows per bands R. So that's for R values, and false negative probability for Fn probability. So the false negative probability, the highest is 0.941153, and that is when number of bands is 10, number of rows per band is 10, and the lowest is 2.03, and so on to the power minus 10, and that's when number of bands is highest, 50, number of rows per band is lowest, 2. Let's write a definition to do this calculation. So, definition: evaluate false negativity probability. So we will input similarity threshold, and similarity threshold is 0.6. Similarity threshold, and comma, number of bands, which is the value of B, and number of rows in band, which is the values of R, and it retains bracket 1 minus similarity threshold, that is 0.6, to the power number of rows in band, which is the value of B, and that calculation raised to the power a number of uh, rows in band. Oh, okay. So 1 minus similarity threshold to the power number of rows in band, so which is to the power R, and then the difference raised to the power of number of bands, which is B. So let B values equal NP dot array of 10, 20, 30, 25, and 50, and let R values equal NP dot array of 10, 5, 4, 2. Let Fn probability equal NP dot zeros of length 4. Let threshold equal 0.6. For pair index in range of length B values. Now B values is 10, 20, 25, 50. So the length of B values is 4. The range will be from 0 to 3. So for pair index in range in 0 to 3, 0, 1, 2, and 3, Fn probability of pair index equal evaluate false negative probability. So it's calling this function here, and the input is threshold, which is 0.6, and that is similarity threshold, and B values pair index. So B values at that position, so 0, 1, 2, 3. So say if pair index is 1, that B values at position 1 will be 20, and R values at position 1 will be 5. Print, tabulate, zip, B values, R values, Fn probability, comma, headers equal number of bands B, number of rows per band R, false negative probability. So let's run this, and we get this. Then we find best B and R. setting for false negatives of 60%, similar pairs to be at most 10%. So now 100, so 100 is the number of hash functions, so which is 100. 100 divided by minimum of b values of where fn probability is less than or equal to 0.1. So if you look at the false negative probability less than or equal to 0.1 is the very last one, 2.03 exponent minus 10. And that's when b equal 50 and r equal 2. So yeah, so minimum of b values, so less than or equal to 0.1. So there are two values actually, 0.0311 and so on, and 2.037 multiplied by 10 to power minus 10. So and then when we take the minimum of the b values, 25 is the minimum. So 100 divided by 25 is 4, and integer part of that division is 4. So print bracket. So we will have, so what we are printing is optimal pair for B and R, B equal, so Kelly braces, we will put in some values here, R equal, Kelly braces, we'll put in some values in place of 1, dot format. So the first value 0 will be minimum of B values, Fn probability less than or equal to 0.1, and we just found that was 25. And then the second value r will be integer part of 100 divided by minimum of b values, fn probability less than or equal to 0.1, and that is 4. So optimal pair for b and r, b equal 25, r equal 4. So this in this set of commands here, this finds the optimal B and R. Let B optimal equal minimum of B values where Fn probability is less than or equal to 0.1, and let R optimal equal int of 100 divided by B optimal. So print optimal pair for B and R, B equal Kelly braces 0, comma R equal Kelly braces 1, dot format bracket B optimal will be put in place of 0 and R optimal will be put in place of 1. So optimal pair for B and R is B equal 25 and R equal 4.